You're welcome to our mathematics class. And in mathematics today, we shall be looking at the topic variation. Now, variation is a relationship between two or more quantities. It changes as one quantity results in a change in the others. So what we are saying now is that as one quantity change, it changes in respect to the other quantity. Now there are four types of variation. We have direct variation, inverse variation, joint variation, and partial variation. So we shall take the first variation, which we call direct variation. Now when we are talking about direct variation, we are looking at two variables which are directly proportional to each other. For instance, y is directly proportional to x. It is denoted as this. Now this is the proportionality sign, and so because it is directly proportional, when the proportionality sign is removed, it becomes y is equal to kx. So the proportionality sign has turned to equal to k, and then because it is directly proportional, we will just write it straight as kx. Now where y and x are the variables and k is the constant, hence we will have it that making k the subject of formula, so k will be equal to y over x. So we shall look at some questions in this line. Question 1. If y varies directly as x and y equal to 7 when x equal to 1 over 6, find the value of y when x equal to 2. Alright, so here is how it is done. So we have our first example. We have y varies directly as x. So we have our proportionality sign replaced by equal to kx. In the question we are told that y equals to 7 and then x equal to 1 over 6. So what we have to do is to substitute y and x for 7 and 1 over 6 respectively. And so we have it as 7 equal to k and then x is 1 over 6. Alright, so with this we have 7 equal to k times 1, which is k over 6, and then we cross multiply. So when we cross multiply, we find that k equal to 7 times 6, which is 42. So here is the value of k. Now we are now told that what if we have the value of x to the 2? What will be the corresponding value of y? And so we'll bring our equation back. We have y equal to kx. We are looking for y. Here we use the k, which is a constant, so we have it as 42 multiplied by the value of 2, the value of x, which is 2, and so we have it as 82. Alright, so that's the answer for, that's the value of y. So if we have other values of any of the variable, we will use the same constant, which is 42. Example 2. If y varies directly as x squared and y equal to 3 when x equal to 2, find y when x equal to 3. Alright, so we have it as y varies directly. So we have y varies directly as x squared. Now if y equal to 3, okay, so we have y equal to kx squared. So if y equal to 3 and our x equal to 2, find y when x equal to 3. So let's substitute 3 and 2 for the values for y and x in the equation. So here we have y equal to 3, so we have it here 3 equal to k 2 squared. So 3 equals to 2 squared is 4, so we have 4k. So k equal to 3 over 4. So that is the value of k. Now we have it that we should find the value of y when our x equal to 3. So we'll bring the equation back where y equal to kx squared. So y equal to, the value of k is 3 over 4, so we have it as 3 over 4 over here, multiply by x squared. X is 3, so x squared is 9. So 3 times 9 is 27 over 4. So that is the value of y. We move on to the next type of variation, which is called the inverse variation. Now in inverse variation, we have one of the variable inversely proportional to the other, and it is written like this. For instance, we could have y is inversely proportional to x. This is the proportionality sign, while the inverse is 1 over, and then we have our x. Alright, so when the proportionality sign is removed, it is replaced with equal to and then kx. So the k replaces 1 that is above. Hence, we could make k the subject of formula, and we have it that k equal to what? X, y. In the inverse variation, we have it that k, which is the constant, is the multiplication of the two variables. Now let's look at an example. Alright, so let's take an example under inverse variation. Example 1. Given that y is inversely proportional to x squared, and that y equal to 2.5 when x equal to 10. Calculate y when x equal to 25. Alright, so we calculate it like this. We are told that y is inversely proportional to x squared. So when we remove the proportionality sign, we have it as y is equal to k over x squared. Now we're told that the value of y is 2.5. So y equal to 2.5 when x equal to 10. So we substitute those into the equation. We have 2.5 is same thing as 5 over 2. So we have 5 over 2 equal to k over x is 10. So we have it as 10 squared. So we have 5 over 2 equal to k over 10 squared is 100. Okay, so we cross multiply, and when we cross multiply, k multiplies 2, which is k2, equal to 5 multiplies 100, which gives us 500. So making k the subject, we have 500 divided by 2, and that leaves us with 250. So the constant k equal to 250. The question continues that we should calculate y when x equal to 25. So y and then x equal to 25. So we bring back our equation, which is y equal to k over x squared. So we are looking for y, and then we have our k to be 250 over x, which is 25 squared. That is 250 over 625. Here 25 gives us 10, 25 gives us 25, 5 here 2, 5 here 5. Hence y equal to 2 over 5. Okay, so let's move on to example 2 under inverse variation. P is inversely proportional to Q, and Q equal to 4 when P equal to 5. What is the value of Q when P equal to 25? So we have the first question, which says P is inversely proportional to Q. So we have it as P equal to K over Q. Alright, so that means K equal to PQ. Now we're told that Q equal to 4, so we have it as Q equal to 4, and then P is 5. So we have it as 5 times 4, and that gives us 20. So the value of K is 20. Now we're now told to find the value of Q. So we are looking for the value of Q if there is a change in P to be 25. So we bring our equation back, which is K equal to PQ. K is 20 and P is 25 times Q. We'll divide both sides by 25. So we have Q equal to 20 over 25. 5 gives 4 and 5 gives 5. So the value of Q equal to 4 over 5. So we take example 3. It says if x varies inversely as the square root of y, and x equal to 4.5 when y equal to 25. Find y when x equal to 15. Alright, so to solve that, we're told that x is inversely proportional to the square root of y. So meaning x equal to k over square root of y. And so we can say that k equal to x square root of y. Now we're told that x equal to 4.5, then y equal to 25. So we are looking for the value of k. Hence k equal to 4.5 multiplied by the square root of 25. So we have 4.5 multiplied by 5, and that leaves us with 22.5. all right, so we have the value of our k to be 22.5. We're now told that we should find y when x equal to 15. So we bring our equation back, which is k equal to x square root of y. Hence our k is 22.5 and x is 15, then square root of y. So we divide both sides by 15. 22.5 divided by 15 will give 1.5, and then 15 cancels 15, so we're left with square root of y. So what we'll do next is to square both sides. We are squaring both sides because we want to eliminate this root. So this cancels this, and then the square of 1.5 is 2.25. Hence y equal to 2.25. Alright, so we'll move on to joint variation. So joint variation has three or more variables which are related. Let's take this example. The mass m of a wire varies jointly with its length L and the square of its diameter D. 1 kilometer of wire of diameter 2 mm has a mass of 28 kg. What is the mass of 500 meter of a wire of diameter 3 mm? Alright, so let's first interpret the equation. We're told that the mass of a wire varies jointly with its length and the square of its diameter. So the diameter squared. Okay, and so we'll have it as m equals to KLD squared. So we're told that if we have a length of 1 kilometer, so length of 1 kilometer of the wire of diameter 2 millimeter has a mass of 28 kilogram, we're asked to find the mass. All right, so we are asked to find the mass of 500 meter, so length is 500 meter of wire of diameter 3 millimeter. So next is to look at all the values that we have here. The diameter is in millimeter and here it is also in millimeter, so that is balanced. Then we have our length in kilometer, but over here the length here is in meter, and then we have our mass in kilogram and we are looking for our mass here. So what we can do is to ensure that the masses they correlate with each other. So we could make this 1 kilometer, turn it into meter. So 1000 meter equals to 1 kilometer, and so we have this as 1000 meter. Alright, so we shall make use of this particular information here to get the value of our constant, which is k. Now let's make k the subject of this equation. We have k equal to m over L d squared. So to make k the subject is to make it stand alone, and so L d squared comes over here by dividing both sides by L d squared. Alright, so we have our m, which is 28, over then L, which is 1000, times d, which is 2 squared. So we shall have k equal to 28 over 2 squared is 4. 1000 times 4, that gives us 4000. And so 28 divided by 4000, 4 into this gives 7. We shall have 0.007. So here is our constant. Now we have to find m using this same equation. we have m equal to k, which is 0.07, or we can make it 7 over 1000, which is this, multiplied by L, that's 500, multiplied by d square, which is 3. So we have it as 3 squared, which is 9. So all this cancels this. 5 here, 1, then we have 2 here. So 7 times 9 is 63 over 2. 31.5 kilogram. That is the mass. So let's take another question. We have that P varies directly as Q and inversely as R squared. If P equal to 10 over 3, when Q equal to 5 and R equals to 3, A, obtain the equation connecting P, Q and R. B, find P when Q equals to 9 and R equals to 12. Alright, so we have it as, we are told that P varies directly as Q and inversely as R squared. Alright, so with this, we'll use this formation, and so removing the proportionality sign, it becomes P equal to KQ over R squared. So from the question, we're told that Q equal to 5, R equal to 3, and then P equal to 10 over 3. So making K the subject of formula, we have P equal to KQ over R squared. What we'll do is that we'll cross multiply. So P multiplies R squared, we have PR squared equal to KQ. Hence, divide both sides by Q. So we have it as K equal to PR squared over Q. Now substituting the values into the letters. So we have K, which is equal to P, which is as 10 over 3, multiplied by R squared, which is 3. And 3 squared is what? That's 9. Alright, divided. So we have it as divided by Q, which is 5. So 3 here, 3. 10 times 3, that's 30 divided by 5, and that leaves us with 6. So 6 is the value of K. The A part has been solved, which is that P equal to KQ over R squared. Now for the B part, we're now told that we should find P when Q equal to 6 and R equal to 1.2. Now to find that, we will bring the equation where P equal to our K is 6 multiplied by Q, which is also 6, over R squared, which is 1.2 squared. So we'll have 6 times 6, which gives us 36, over 1.2 squared is 1.44. And so we'll divide it 37.5. So that is the value of P. Moving on to partial variation. Is a variation that consists of 2 or more parts that are added together. So in this part, the emphasis is that they are added together and then it contains 2 or more parts. Let's take this example. Suppose Y varies as the sum of 2 quantities, one of which varies directly as Y and the other inversely with X. If when X equal to 3, Y equal to 6, and when X equal to 7, Y equal to 9, find the relation between X and Y. Okay, so we're told that suppose Y varies as the sum of, so Y varies as the sum of 2 quantities, one of which varies directly as X and the other inversely with X again. So inversely, so we add it inversely with X. So Y varies directly as X and also varies inversely with X. Now what we are going to do here is to introduce 2 constants. a constant with this first x and a constant with this inverse of x. So we have it as y equal to ax plus b over x, where a and b are constants. If when x equal to 3, y equal to 6. So if x equal to 3, y equal to 6, and when x equal to 7, y equal to 9, we are to find the relation between x and y. Alright, so let's substitute our values. Y, so for the first aspect, which is this, y is 6 equal to a, which is a constant, and x here is 3, plus b, which is a constant, over 3 as well. This is the first one. This can be written as 6 equal to 3a plus b over 3. So this is our first equation. Then the second one says when x is 7, y is 9. So y is 9 equal to x, which is 3. So we have 7a plus b over 7. This is our second equation. So we could solve this simultaneously by multiplying here. Now let's say we want to eliminate this a. So we could multiply by 7 here and multiply by 3. Check our video on simultaneous equation using elimination method to understand this better. So we multiply by 7. 6 times 7 gives 42, equal to 3 times 7, which is 21a, plus 7b over 3. And then 3 times 9 is 27, equal to 3 times 7, which is 21a, plus 3b over 7. So we can call this equation 3 and call this equation 4. So equation 3 minus equation 4, and that will leave us with 42 minus 27, that will be 15. Then 21a minus 21a, that's 0. And then 7b over 3 minus 3b over 7. So we have this as 21. 3 into 21, that's 7. 7 times 7 is 49b. Minus 7 into 21, that's 3. 3 times 3 is 9b. So we have 49b minus 9b. That leaves us with 40b over 21. And then we have 15 here. So making b the subject of this equation, we have 15 times 21 over 40. So 5 here is 3, 5 here 8. So we have 63 over 8. That's the value of b. Alright, so we substitute 63 over 8 as b in one of the equations. So let's use equation 1. Okay, so we substitute 63 over 8 into b in any of the equations. So we have 3a plus b over 3 equal to 6. So to substitute b, I would suggest we make b the subject of this equation. So we have 3 over here. 1 into 3, 3. 3 times 3 is 9a, plus 3 into 3, 1. So we have b equals to 6. So we have 9a plus b equal to 6 times 3. That's 18. Now we can bring in our 63 over here. So b now is 63 over 8. So we have 9a plus 63 over 8 equal to 18. So bring this over here. We have 9a equal to 18 minus 63 over 8. That's divided by 1. And we look for the LCM. The LCM here gives us 8. 1 into 8. So we have 144 minus 63. We have 81 over 8. So we are saying that 9a equal to 81 over 8. So we have 9a times 8 equal to 81 after we cross multiply. So what we could do is to make the 9 and 8 come over here. So a equal to 81 over 8 times 9. Make it a the subject. So 9 here 1, 9 here 9. So we have a equal to 9 over 8. So we are now told to find the relation between x and y. And to find the relation between x and y, we are going to do that by substituting the value of a and b into our equation. So what is that going to look like? So don't forget that our original equation was y equal to ax plus b over x. The value of, so y equal to a is 9 over 8 x, and then b is 63 over 8x. And this could be rewritten, after finding the LCM of this, it could be written as 8xy equal to 9x squared plus 63. That's the answer. All right, so let's look at this question. If A consists of the sum of two quantities, one is a constant and the other varying as B, and if when B equal to 3, A equals to 2, and when B equal to minus 2, A equal to 0, find B when A equal to minus 2. So we take that here. We are told that A consists of the sum of two quantities. One is a constant, so let's take it as K, and the other varying as B plus B, and that B has a constant attached to it, which is N. So where K and N are constants, so we are told that when A equal to 2, B equal to 3, and then when B equal to minus 2, A equal to 0. We are going to substitute the numbers into this equation. So if our A is 2 equal to K plus our B here is 3, so we have it as 3N. Alright, and then we have, this is the first equation, and then the second equation is A is 0 equal to K plus, then B over here is now minus 2N, and here is equation 2. So we are going to solve this simultaneously. From equation 2, we could make K the subject of formula by saying, now this particular one means 0 equal to K minus 2N. So making K the subject, it will become K equal to 2N. So substitute 2N for K in equation 1. So we have 2 equal to 2N plus 3N. So we have 2 equal to 5N. Then N equal to 2 over 5. Then we'll substitute 2 over 5 for N in equation 2. So let's take this as our equation 2, where we have 0 equal to K minus 2N. Alright? So bring this over here, that's 2N equal to K. And so we have 2 multiplied by N is 2 over 5 equals to K. So that's 4 over 5 is the value of K. Now we are to find the value of B. So we are looking for B when A equal to minus 2. Now in this aspect, we will bring our original equation back. So we have the value of A. We have the value of A to be minus 2. K from here is 4 over 5. Value of N here is 2 over 5. Alright, and then the value of B is what we are looking for according to this. So multiply by B. So we can, we have minus 2 equal to 4 over 5 plus 2B over 5. Bring this over here. We have minus 2 minus 4 over 5 equal to 2B. This is over 1. So we have 5. 1 into 5, 5. 5 times 2. So minus 10 minus 4 equal to 2B. We still have over 5 over here. So we have minus 14 over 5 equal to 2B over 5. We cross multiply and we have, now these two 5s will cancel each other. So we have minus 14 equal to 2B. We'll divide both sides by 2. And then we have b equal to minus 7. So the value of our b is minus 7.